I'm Chris. I'm the author of Cascading. I'm going to kind of get into some of the technical details and what these projects are. Really going to spend more time on as much time on the philosophy and why this is different. This is, if you came from Alan's talk prior about Hive, this is not a competition. They're complementary. Hive and Cascading and Lingual are two separate things, have different philosophies or for different use cases. I'm definitely going to cover those cases. So to get started, I'm going to be honest, I have no idea what really big data is, and I'm not a data scientist. I spend my career as a data architect or data engineer, if you will. And this talk is about Lingual. It's an ANSI SQL parser on Cascading. It's a project for me and Julian Hyde, who's now at Hortonworks, who wrote Optique. And I'll get into a little bit more details on those technologies, obviously. So bear with me. So why is Hadoop even in big data a thing? There's really two core philosophies here, and this is the underlying pinnings between Cascading and Lingual. First off, more is better. It's kind of obvious. More data, more algorithms, more computers. And more tools. We want to have all the degrees of freedom that we need to do the things that we're doing, right? Cascading, Lingual, and the Cascading ecosystem are definitely huge pieces of that. More importantly, worse is better. We want to we don't want bureaucracy. We don't want red tape. I don't want to create upfront design schemas. I want to use my data. I want to create applications. I want to output data. If someone has data and I can't use it, I go back to the raw data and use what I'm going to do. If I don't have the tool I need, I can write the tool, right? You just want to be productive. You don't want a lot of things in your way. So again, no upfront design, no red tape. So then why Cascading? We have MapReduce, but can you think in MapReduce? We have Pig and Hive. We have all these other technologies, but they have constraints and boundaries. Cascading's intent is to let you do hard things. In one line of code, you can write a pig script, right, and ask your application data. But can you do gene alignment realignment algorithms, right, that are optimized, right, that deliver those results to your customer who actually sent you the raw data? And as a single application, not a chain of applications, not a bunch of documents and XML things and lots of different jars. Single application I can deploy into the cloud. More importantly, as you build these applications, the intent is to retain the conceptual integrity of the design. Again, if you take 15 applications or 2 applications, 2 different jar files, Pig, Hive, and Uzi, and all these things, you lose that integrity. You're now just an integration guy. You're making all this stuff work, and they're in different environments. And things are always changing. Your data changes. The environment changes. You move from QA to production, staging to production. You're in Amazon one day, the next day you have enough money, you buy your own cluster, the environment's different. You have to change your applications accordingly. So this is a key quote, and it doesn't apply fully, so think about it. The faster you can get answers to your questions, the quicker you can innovate. This is how you differentiate yourself from everybody else in the space, right? This is how you innovate. You don't innovate on having more capital. You innovate using your brain, right? So it's true for data, right? I'm using Greenplum or something, and I'm using MicroStrategies, asking lots of questions to get answered. But it's the algorithms. They change as you move through your scale of data, or as your problem changes, or as you get more feedback on its quality of the results. But also your architecture. If you can't prove out an architecture immediately, you're trapped. And the architecture of a system is more costly than everything else. So you have to be able to prove these things out as quickly as possible. So Cascading was designed to allow you to have all those qualities, but also be productive. In its essence, it's a Java API. It's very, very focused on separating business logic from integration logic. Read and write files, read and write JSON, read and write from Oracle to Elasticsearch. That's not the same thing as performing the math that you came up with, right? Doing a decision tree or a regression or a random forest model. Who cares where the data comes and goes to? You should be able to build reusable libraries that anybody can use. And as you move through your organization, you integrate with different systems because that's just how it is in your company, because companies are messy. Worse is better, right? It's testable. We're all Java developers or JVM level developers. You want to write a unit test. It's important. Thus, we work in any JVM language. Scalding and Cascalog are actually 2 languages on Cascading. They're Scala and Clojure, respectively. It's still Cascading, but guess what? You get all the goodness of Scala and Clojure. And there's a huge community support. Elasticsearch ships with integration for Cascading, so you can load data directly into Elasticsearch from a 1,000-node cluster with one little tweak of your application API. So there's a full ecosystem. The ones I'm really going to talk about are Lingual. But pattern is for machine learning scoring, and then obviously scaling and Cascalog. And there's other things happening. And also, we'll briefly touch on the fact that we run on MapReduce, but by early summer, we'll also be running on Taze. And so Hive will be out in Taze soon. They're proving the ground, making sure it's a thing. Our query planner will also support Taze as well. So all the lift that Hive gets or anything else that gets on Taze gets that. So cascading will run on Taze, and anything on top of cascading inherits that without you having to change any of your code for the most part, right? So quick stats. Cascading ecosystem's been around since 2007. It's one of the oldest projects there is other than Hadoop itself. We have a 3.0 out now, which has a brand new query planner. I'm not going to go into detail on that. Just so there's no confusion, it is open source. This whole ecosystem is open source, and there's all Apache license, so use it freely. You don't have to pay anybody any money. We support all Hadoop distributions. Every distribution there is runs all the compatibility tests. So Lingual, Cascading, Scalding, Cascalog are guaranteed to run on any distribution that's run our tests, and they all incorporate our tests directly in their builds. Horton ships with Cascading, Cloudera ships with Cascading, MapR ships with Cascading. They all have it in their distributions already. Even Amazon has it. Their managers run the tests just to make sure that they can prove that when the top 20% of all the revenue-generating companies are running Cascading, which they do, it's going to work for them on any version that they care about. So Lingual, what is it? It's an ANSI SQL parser on Cascading on whatever we happen to be running on. And we're hoping to also be Spark and other technologies in the future as well and keep that transparent. So again, how is this different from all the other projects that we see? About a year ago, everybody's like, SQL on Hadoop, right? And so we were one of those. But again, the philosophy, the intent is much, much different. It is not intended as an ad hoc interface, right? It's not something you can go to and get really fast questions to your answers. That's not the intent. The intent is to allow you to be as standard client as possible, right? We are ANSI. So actually, the parser in Lingual is Optique. So Julian Hyde, he's now at Horton Works. Hive is adopting Optique as a cost model optimizer. Well, we've had it in there for over a year. We're the ones that actually sponsored the work. And so we have all the expressiveness of Optique, and we have the computing power of Cascading underneath, and all the standards compliance that many organizations are pressing into Optique now. So correlated subqueries and all that other goodness, as it emerges in the optimizer, will also emerge directly in Lingual as well. But the intent here is to help you migrate workloads from expensive systems onto a less expensive Hadoop cluster. Think about it. You've got a multi-million-dollar Greenplum or Teradata cluster. It's running lots of workloads. You've got a guy with MicroStrategy sitting there asking lots of really hard questions. You're paying him a lot of money, right, and to innovate. And again, the response time to innovate to your answers improves your innovation, your ability to innovate. So the last thing you want is a lot of low-class loads on your cluster competing for resources. And so his queries aren't taking 2 seconds, 3 seconds, they're taking 10 minutes, 20 minutes, or whatever. But more importantly, you've spent millions of dollars in that thing. You want more capacity. Why don't you just move off the low-class workloads, move them onto that Hadoop cluster you've already put in production. Have it do the really boring stuff, and then move the data back into the Teradata, Greenplum, Oracle database to free up load, not have to buy any more licensing. This is the point of Hadoop, right? It's same way that you have different caching strategies. You have inexpensive disk but lots of storage, but you got RAM, which is more expensive but less storage, right? You have to pick and choose. The same thing with computing power. The flip side of the problem is the best practice to put all your bits in Hadoop, right? They told us 2 years ago, put everything in Hadoop and you'll figure out what to do with it. Okay, that's what people are doing. Now they're trying to figure out what to do with it. The problem is you have people with lots of different sets of skills, right? You got a guy who's the multi-$100,000 a year MapReduce programmer who can write 2 MapReduce jobs that solve all problems in the known universe. Then you've got another guy who writes just standard Java, and he doesn't want to think in MapReduce. He's just got a very big backlog of things to do. So he picks up Cascading or something, or maybe Pig or Hive. But then you got the guys the business guys, they've already prototyped a SQL statement, or they need some data, right? So the prior issue is, if I'm moving workloads onto Hadoop, I got a guy who writes SQL for a living, and now he wants it on Hadoop to be applied to a larger volume of data set. So in reality, the flip side is, they actually want that data off. So at Etsy, what they have is I believe it's a Teradata cluster, and they have 10% of their data on it. All their other data is on the Hadoop cluster. But their nightly reports have always only come from the 10%. They really want those reports coming from the 100%, and they only need them once a day in the morning. So we've already prototyped it in Teradata. Why can't you run it on Hadoop without having to rechange all your code or use other things? So we help you get the data off Hadoop into other technologies to be successful. So without having to retrain people on the nuances of whatever the underlying language is. So Lingual, what does it come with, right? Obviously, ANSI compatible SQL parser. It's ANSI, and it's as compatible as we can make it within bounds of Hadoop. We've got a lot of things we still have to add. I'll kind of cover a couple slides on what's missing. It comes with a JDBC driver. Drop it into Mondrian, drop it into Pentaho, and guess what? OLAP engine for Hadoop, right? Works great. And actually, we run 7,000 Mondrian tests against the Cascading JDBC driver to make sure that you can actually do that, right? It also has a cascading-like API. It's on top of cascading, but we also make it feel like cascading. And this is extremely important when you have 5 SQL statements and a cascading unit of work and a something else unit of work, and you want them to work together as a jar file, not 5 applications in an XML document, as a single jar file with command line arguments that you can put it in Git, and you can go from development to QA to staging to production, right? Extremely important. Comes with a shell. Everything has to have a shell, has a shell. We've actually had to fork J-line query, some SQL line, and give it some extra enhancements. So we have some additional features. It knows all the history. So you can actually go back and run queries on your history. And it's actually quite compelling when you're actually doing data mining, if you wish to do it for that. There's a catalog, and more importantly, I'm talking about the data provider. So ANSI SQL, we're shooting for 92. I think we have some 2003 stuff. I don't believe we have the correlated subquery in yet. The new Optique has it, so we'll need a new Lingual. We have lots of types, temporal types. We've had date time since the beginning. In, case, from. We have also insert into values, which actually I don't know if I have listed on here. So you actually can write data from a SQL statement into Hadoop if you want to. It's not performant, even if anything support. You still have to parse it. You have to do all this stuff. But if you are in your own query, it's a subquery, and it's an insert into a subquery, you can use that. It actually I think it actually translates into an in or a case or something like that, or vice versa. But you can do some pretty complex stuff just today, even though we're not 100% coverage, right? So actually more detail. These will be online. I'm not going to go through this because I'm not a SQL guy. But there's a lot of things that we do have, and a lot of things we don't just yet. But the having, the group by the where, obviously, are all interesting. But again, I think some things are crossed out. So limit and offset and fetch are fairly hard to do. We'll be able to have that at some point. So Lingual provides 2 interfaces like I talked about, right? So the first one is the Cascading API. The intent here is to allow you not just to port a SQL statement over or a set of SQL statements over, to build applications that are a mix. Worse is better. Everything's heterogeneous. You have lots of little bits. You have some cascading stuff that you have from a library, a couple of SQL statements that it's just easier to express, in SQL. You want it to glue it all together as a single thing. And so how does that look? So you just create a simple definition. So right here we have a table name. We map. So, time permitting, I didn't have a chance to introduce you fully to cascading. We have a couple of very simple concepts. A tap. So the pipe metaphor is kind of overused in cascading, but it's there. And so taps are integration. They read and write data. Simple as that. They're responsible for where does the data live, and inside a tap is what we call a scheme, fields, types, stuff like that. So that's how you process the data. What's the format? A unit of work, the algorithm is called an assembly or a pipe assembly, if you will. It's a big DAG of information, many inputs, many outputs. In SQL, lots of inputs converge to one output. In cascading, many inputs can go out to many outputs. So if you really want to have a complex system that does fan in, fan out, trivial, not a problem. It's natural. In this particular case, we have a SQL statement, which we don't show for brevity, but let's assume it has from those 2 tables. All I have to do is put the table name and label the tap, which is where the data reads from, and it automatically uses the table, that tap information during the optimizer to actually resolve to guarantee the SQL statement can be satisfied from the fields available in the data. So we actually look at the data and we'll ask it what the fields are. We'll go to whatever the headers or the catalog or whatever we have to. And so the query optimizer guarantees a plan up front before it even executes. In just a few lines of code, now we have a single flow, which is a unit of work in cascading. It marries the taps and the pipe assembly together under the hood, And in this case, our pipe assembly is really just a SQL statement, right? It's pretty trivial. And we have now a flow. The query planner kicked in. It actually threw no errors. And if I run start or complete, it'll start submitting jobs into the cluster. It's very trivial. There's no installation here, guys, right? You didn't do anything. You don't have to have a catalog manager. You don't have to have anything running. You have to go make sure all the right versions of everything. You have a self-contained jar file with any number of flows that are related to each other. And we have another concept called a cascade where you take 100 flows, you stick them in the cascade, it'll order them all by dependency and run them like a makefile. And if the data's not stale, it won't run the job. So if you want to rebuild world, touch all your data and it rebuilds everything. If you only have one file change, only the jobs that touch that data will run. And this can participate in building these applications. Again, worse is better, but you have to have conceptual integrity. You have to be able to take a single application that's maintainable by the guy that comes after you, and he can also continue to be successful building these applications. So it's not a lot of code, right? It's Java. There's still boilerplate. It sucks, right? I mean, there's a lot of stuff we have to do. But the reality is we can get it down simpler and hide all these implementation Ds from you. Obviously, JDBC, if you want to use JDBC, feel free to do so. It's actually intended for you to drop it into other things like Toad or Squirrel or whatever, or R. I have an example of that in a little bit. But the real intention here is, boom, I just use a JDBC driver, do my thing. And this is where, so what actually happens is we don't read the results directly into the driver. We have to write it out as a file, and then you actually have access to that file out of band if you want to. You can specify where the target location of the result, even if you don't do a select insert into. So an insert into will give you the row count as a result. This one actually writes it to the file and then opens up the file and allows you to start reading it at hand. And so, again, it's still, well, actually you're not seeing the do something, in theory, is iterate over the result set and print stuff out or do something relatively useful. But that's not the point. The point is standards compliance. Put the JDBC driver somewhere that actually expects a JDBC driver. That actually parses actual ANSI SQL. So how does this actually work in the real world? So ignore my crazy architecture diagrams. But the intent here is you're on your desktop, you got a JDBC driver, and there's your cluster, right? It's self-contained. The driver is actually in Maven. You pull it in, boom, done. It's got all its dependencies in it, or you can drop it out, or you pull out sub-dependencies down, and you have a single app. But if you drop this into Pentaho, for example, it's completely self-contained. When the Pentaho runs a query, or Maven runs a query, it will actually use the driver as the job jar, right? It's ready to go. You don't have to package anything. You don't have to build anything. Just drop it in there, and it magically runs the query and submits itself as the job jar into the cluster, right? And then it's actually one SQL statement becomes assembly, becomes a flow, maybe two MapReduce jobs, and then we run one job, then run the other job, blah, blah. It's just cascading underneath, right? So we do have a shell, right? Bang tables. Look at that. We have tables in there. So the challenge is that in this particular case is that with the JDBC driver and you're running random tables, we have to have a metadata catalog. So if you're using the Cascading APIs, remember we had that floatdef, and you can say, here's the table name, and here's the tap, and it's just some file somewhere like S3 or somewhere, or JDBC driver. It's irrelevant. Taps can point to Oracle servers. They can point to files in HDFS. They can point to Elasticsearch. It doesn't matter, right? I can make anything. Let me back up again. Anything can be a table. It's irrelevant. I can write this SQL statement, and I can magically swap these guys out with anything, and that SQL statement will run. That's tremendous value right there, right? You can build a single contained application that reads Oracle, writes Elasticsearch from a SQL statement, right? And it's self-contained, and only operations guy has to deal with this out of Git, and it has a very consistent build file, just like and you even have unit tests if you need to, right? You test the integration separately. This is the separation of integration and business logic. So the problem with here on the JDBC driver is I have to either come up with some crazy voodoo, right, to tell it where my files are and how to map files to tables and stuff, and that's totally doable. If you want to do that, it does keep it self-contained, right? We can point to a location. We say this directory is the schema called examples, and everything in the examples is that every directory in examples is now a table. I'll look at them, inspect them, look at their headers, see their type information, and boom, I've got this magic on-the-fly table catalog that no installation. It just inspected my file system and asked the taps but that's what it does. It looks inside and says, hey, what are you? What are you made of? But in the case of JDBC, you drop it into Mondrian, you can still give it that voodoo. But if you use our catalog tool, and do I have that? No. I'll kind of talk about that real quickly. From the command line, you can map any resource as a table. But more importantly, what I talked about up here is this guy here. It's self-contained. He only knows what he knows. He has the native formats are text files and some of the cascading native formats. That's it, right? But, so there's a challenge. But first off, if it is simple text, you publish the file as a table name in the catalog that's it's local, shared on the HDFS cluster. Anybody can use it. And I think I have a little more detail on that, but and how we get around some of the limitations. So there's a shell, boom, bang, bang, tables. Look inside the catalog from the shell. More importantly, run a subquery, boom, get query. You can't really see that terribly well, but it was a very simple query. Well, it's a complex query, but it's a very simple set of results. But more importantly, again, it's a JDBC driver. Drop it in R. Now, everything in your Hadoop cluster is available to you from R, right? So here's some R voodoo. Drop it in, set it up with this jar. I think that's, and run it. Right? So the value is anything that's available in Hadoop that Cascading Lingual can see can actually be sucked into R, and you can do your trainings and modeling directly in there. This is the results of running that. But here's the challenge, right? So like I said before, if you're running the Cascading API, you can use any tap that you can pull out of Maven in your project to talk to any data there is. Avro, JSON, Protobuf, Thrift, whatever you want, right? Any location, any other JDBC driver, any other backend system like Cassandra, right? But how does the JDBC driver do this without rebuilding the JDBC driver? So, again, like I mentioned before, we have a Fatjar in Maven. It's actually our own Maven repo, so we have more control, flexibility. And then the jar itself is loaded into the cluster. So, but more importantly, we have the ability for you to publish. If you actually say this file is Avro, when you actually map it into the catalog and you give it the Maven spec, now that Maven jar will be pulled out of Maven and put and deployed into the cluster on the fly when you run the query, along with the job jar, and all of a sudden you can read anything that you want directly into other applications. Let me see what the next slide is. So to give you an example, let's say you've got some Avro files and some text files and S3. And all you really want to do is take them, join them, and shove them into Redshift. But you just want to do it from Squirrel, right? So you've already have a catalog. And you said this file and this S3 bucket is TSV, and this one is an Avro file. Here are the fields and different type information. Oh, and here's the JDBC URL to Redshift. And here's the jar file for loading Redshift, which we have in an S3 bucket, in a Maven repository. Now you'd run the SQL statement that you can't see. But if you actually go to this tutorial, it'll show you how to do this. Just type the SQL statement. It'll read the data, do the join on the Hadoop cluster, and load the results directly into Redshift. And actually with Redshift, what's actually interesting is you don't load into Redshift. You load into S3 bucket, and then you notify Redshift, and then it looks in S3 bucket and loads it for you. So it's actually more reliable than having to talk to a Redshift cluster that may go away on you, and then that sucks, and your reducer starts over again, and it gets very, very frustrating. So finally, since everything is actually on Cascading, we actually have the way to actually visualize the running applications. And so we have an online hosted service. If you actually run Cascading, and you put our plugin in play, it'll automatically unwind and visualize any applications you've written in Lingual and Cascading and Pattern and Scalding and Cascalog, and allow you to automatically visualize and actually see the code executing to be able to debug these applications. It's completely free. It's just it's a service that we've provided for users. To give you a sense, you can use it anonymously, but if you did trade an account and get an API key, you can crash a lot of jobs like I do, and you can see your history. So you log in, you see the history of all the applications. In this particular case, I opened up the Lingual shell and started writing SQL statements in a single shell. And sometimes they would hang, so I'd kill the shell and get out, and you can see that happened a couple times. But then when I actually did run, this top one up here, we could see that it was running for X period of time. I can actually drill down into that. And so what happened here is, this isn't perfectly ordered, but you can see what we're not doing right now is percolating up the SQL statements. You're just seeing the raw job names. But every SQL statement I wrote translated itself into the assembly I was telling you about. So here are the taps. Here are the intermediate taps that Cascading has to create in order to bind MapReduce jobs. So a unit of work, something that you actually do in Hadoop, isn't a MapReduce job. It's not 2 MapReduce jobs. It's probably 10, 20 MapReduce jobs. It could be 100 MapReduce jobs. The simplest thing possible is word count. It's 1 MapReduce job. The moment you actually want to sort the count by some order, it's another MapReduce job. That's just how it is, right? It's a lot of jobs to do simple things. So in this particular case, these were very simple SQL statements. Unfortunately, I wish we were percolating up the SQL statements, but you can see that this one's reasonably complex. It was doing something. A couple of joins, group bys, et cetera, et cetera. These are simple, but I took the results of this one. This is a function. Maybe I was doing some sort of translation or cleanup. Then I ran more statements on the end of that. So imagine I ran this one, and then I ran the other ones. They'll just keep popping up. I can actually see my history as I work through and typing statements and doing data mining and revising and trying to understand how to cleanse the data for a particular purpose. I've actually created my data flow. So if I'd created another query off this one, it would go up here. It'd be conceivable, if not in the very near future, you'll be able to go to this tool like this, and after you've done your data mining, your ad hoc, your analysis, to get the data clean so you can actually use it for a particular purpose, because that's what you spend all your time doing anyway, and you want to do that through SQL, we can capture all the SQL statements for you. And find the one that actually worked, go back 2 months later and find the ones that worked, get the SQL statements, cut and paste them, put them directly into the Cascading API, and guess what you've got? You've got a cascading application with 5 SQL statements and a single jar file that cleanses your data for you. All because you were doing exploratory ad hoc work, and now we actually showed the history of that, right? More importantly, we'll have further screens that allow you to dig down even further and really understand the performance of these as they're actually running. But if this was running, you would actually see that that would be a single mapper, right? This is a mapper, that would be the reduce side. You would actually see this code executing, and then we'd have additional counters and metrics so you can actually see on the raw performance. So we do have a book. That's it. So we got plenty of time for questions. Anything I should cover that was a little vague and foggy? Sure? I hate that question. So Julian has threatened more than once to build an ODBC wrapper, open source. I think Hive has something. I think the intent is to start with that. If you're so willing, yes, go get Simba, drop JDBC into it. We want to do that, but in the open source space, not a lot of people that know C, right? And I guess you could do it, write a raw ODBC driver in .NET, but I have no idea. Unlikely. So we need to get, so it's a challenge, even though it's extraordinarily important, because more than anything, the reality is what you want is a guy with the Excel spreadsheet talking to, what we don't want is a guy with an Excel spreadsheet coming to you asking for data over there in that Hadoop cluster and trying to figure out which data set is the one he wants and have him then try to figure out how to get it into his spreadsheet. Okay, let's be real. People have petabytes of data. They also have megabytes of data. They have lots of megabytes. And actually petabytes, the stuff they really care about on that petabyte is probably only a couple megabytes, right? Maybe a gig, right? The whole point of running a SQL query on Hadoop is to take that really big data set, make it smaller so you can actually get it at human scale so you can manipulate it in a tool that's human scale. Excel is a very human scale. R is human scale, right? MicroStrategies probably crosses into machine scale. So the intent there is, yes, I want this Excel spreadsheet guy. I don't want him to go to another tool. Just use the tools he knows with an ODBC driver, to your point, to get whatever I want and still inherit the quality of him not having to understand the voodoo of is that really an Avro file? Is this something else? He doesn't need to understand the details. More importantly, what you don't want him to have to do is go figure out what the latest version is, because all of our tables are logical. They should point to and be updated to the very latest of things. So every time an application job finishes and it created the new quarterly reports for last quarter, and he wants to pull in some subset of the quarterly reports because it happens to be a really big file, and it's on Hadoop for whatever crazy reason, or it's actually an Oracle database, and he has another thing he wants to correlate with in the join before he puts it into his Excel, he should be able to do that because they're all been published in a very simplified catalog. It also knows and understands how the data was made, what it's made of, and how to integrate it. And then he can pull it in. So yes, the long answer to your short question was yes, we want to do that.
I like you want to.
Huh?
I like you want to.
Well, I think it's necessary. The real challenge is who's going to do it. And so hopefully Julian will muster all his massive resources at Horton and make that happen. And once we have a generic OWC framework, then we can, because it's not hard, right? It's still got to throw the job jar out there and do Java stuff. It's just got to integrate the two. So the other challenge is probably needs to be a gateway, because without having to put Java wherever the OWC driver is, it needs to be a gateway, so you got to stand it up, and it talks to it, and then it does the job submissions. So then that adds complexity and brittleness. So again, the philosophy is let's not install anything we don't have to, right? I don't want a catalog server. I don't want this. I don't want that. I don't want that. I already have HDFS. That's enough trouble as it is. So let me put the catalog file there. So actually, that's where we store our catalog today. It's just a JSON file in HDFS. Just point to it. We'll read it. It's not multi-user. It's not transactional. It probably works for as a couple megs, but everybody gets their own, right? It's the simplest thing you can possibly do that doesn't, where the cleverness doesn't actually break your job 10% out of 5% of the time. So, anything else? Yes, sir.
The media store on Lingual.
Uh-huh.
I was running through the examples on the Maven image and brought up the table between the tables and we all there created some non-tables. Created another connection and it wasn't there. It wasn't shared between my two connections to the same cluster.
I'm sorry? Which? Oh, connection between clusters? So what was the? I'm sorry.
I had two connections to the cluster and I did all the. I built up.
Oh, yeah. So did you do you did create table in the shell? Yeah, it probably didn't commit. It's probably just a bug. If you use the command line tool, it commits on every transaction. So if you use it externally, but if you're using the create table meta stuff, the DDL-ish stuff, I think, it may not save it so everybody else can see it just yet. So that's maybe it keeps it in memory for you. So maybe we need a command to commit, or you just open up an issue. Yeah, that's definitely a problem. But sometimes you have your own workspace where you're doing these sorts of things. So there is something to be said for having it shared, and you can do that. The other thing is, where it's shared is based on the username that you're shelling in as. So if you've logged into Hadoop and someone else logged into John Doe, they're not going to see each other's stuff unless you point to the shared location. Yeah, so that might be also an issue to look at. But yes, we do want to have a server to do all that, or integrate with HCAT at some point. It's just, we don't want to make it a requirement by any means. So, questions? Awesome. No more. Oh, yes.
So I have 27,005 megabyte files.
Mm-hmm.
Right, this is just terrible truth.
Then don't use Hadoop.
And SQL Server is something terrible.
Okay.
I'd love to just shift it en masse. Boom.
Right.
One of the questions, though, is actually the toughest thing to manage is not data, device, not stuff. It's just actually knowing how to find a table. Right? So I actually need really great facilities around metadata management because I generate my SQL from the metadata in the SQL Server.
Okay.
System tables, and I generate loads of code,
Right.
big scary stuff, and it just runs. So I'm using dynamic SQL a lot from the metadata table. So would I be able to have those facilities?
Yeah, we definitely can. There's no reason why you can't. Well, the JBC driver, there's no reason we won't give you a direct API to the catalog. I mean, you could try using HCAT to see if it solves all your problems. But it's. But there's what we do not have right now is a direct API for manipulating the catalog. I mean, there is one, but it's kind of semi-private. So people can actually make catalog operations first class. And that would what you would want. You would actually go look through the catalog, find things, regardless of where the catalog. So that actually is an interesting. So if you want to.
Just throw catalog updates to a table.
Mm-hmm.
So you just tee it, drop it in.
Yeah, some people use SQL itself for its own catalog. That might be typically how one of the interfaces to the JBC driver is to go to the catalog table, which is really something else. But sometimes you just may want a raw API that's more expressive, right? Versus having to go through a result set to get the answers you want, which really you just want to ask for an object called table on and another object called column or something. And so,
So maybe this is a question for later, but do we think that the metadata tables that are supported by JDBC created
Well, you use cascading. I hear what you're saying. Yeah. That's got to be moved to the bar to make that discussion. All right, we're gonna. Anything else, guys? Yes, ma'am.
Why don't I just use Lingual as opposed to just using plain cascading?
What? Using what? I'm sorry.
Using Lingual as opposed to just using cascading.
Okay. Question. Go ahead.
As a developer, I'm not that great in writing SQL queries, and I don't particularly like.
Okay.
People that do that, they already use Hive.
Okay.
Okay,
so the question, I think, is why Lingual over versus cascading? Why do we have, and so versus then just if you're already on Hive or no Hive, use Hive. So, well, developers do that. So sometimes you get requirements that are SQL statements that you want to put in production, but they're not mission-critical apps, but you don't want to write 50,000 lines of code just to write a SQL. So, I mean, in an organization, I go to my business guy, and he goes, here's a SQL statement. I know it works. Can't you just run that? But what you don't want to do is install Hive if you don't have Hive or don't need it on that cluster to have a workload. But sometimes that SQL statement. Yeah, then use Hive. If you have that, that's what they're for. But they're for ad hoc. They're for analysis. You have the data. You put it in there. That's what they're for. I mean, so if you have 3 terabytes a day. So I did a project some years ago where we're getting 3 terabytes of behavioral logic data a day. I had 90 days of history, right, which is compressed and cleaned up. But then I had a 9 p.m. SLA window, right? What I didn't want to do is load a lot of technologies within that window. When I started the job, it was actually a 9-hour, 10-hour job in a multi-thousand node cluster to optimize subsequent queries, like building indexes or partitioning and all stuff, but when they didn't actually improve the performance of the pipeline, because all I had to do was update the 90-day history and cleanse 3 terabytes of data and deliver the retargeting information to a server by 9 p.m. I didn't want to inherit all the other stuff. I also was deployed into Amazon, but I was developing on my laptop, and I had a bunch of liars tell me what the data looked like at the company, right? And they weren't really liars. They just didn't know. So the challenge was I didn't want to deal with the ceremony of architecture, of technology that I had to deploy. I wanted a single jar file that could actually do everything end to end, because I didn't need the optimizations of a catalog. It wasn't necessary. So that's just cascading itself. Sometimes those requirements are best expressed as SQL. Sometimes you take 3 SQL statements and then some cascading code to do the cleansing, but the statements do the math to prove that the application works as a single application. You know, in Hive, you get a shell, you can put Hive in, you can write code around Hive, but it's not as easy to glue them all together without there also having to be expected conditions in the environment, HCAT, et cetera, or a particular version of Hive. You may have SQL statements that are only on Hive 12, it worked on, or something, but you only have 9 because that's all Amazon supports, right? You want to carry in all your dependencies with you where you can to keep the system from brittle. You're exactly right. If you have Hive, use it. It's great. This is not it's not a competition. There are environments where you just need to cheaply as possible get these boring workloads that are heterogeneous, some cascading, some Hive, Lingual, all together in a single thing that you don't have to worry about. You throw over the wall and it's not your problem anymore. And it has a management capabilities to actually then makes it someone else's problem when it comes to operations, right? You don't have that visibility with Hive or other applications. You're debugging multiple technologies in a single application. If you could do this pig and Hive and all this stuff together and raw MapReduce, you're debugging all those together simultaneously when everything is really just cascading. So you're only debugging cascading no matter what you do internally. So it's a subtlety. I get that. But it's every environment's different. If you're throwing it over the wall, there's not a precondition. We're going to move from Horton to Cloudera. How is that going to break all of our Hive queries? With cascading, you never have that issue. With Pig and Hive, Amazon has to change Pig and Hive every time they do an Amazon update of the EMR cluster. It makes it incompatible with the previous one. So is it write once, run anywhere, even though it's a syntax? No, it's not, honestly. Is it extremely performant if you're asking yourself lots of questions over and over again on the same data? That's what it's good for. Then you ask yourself, well, shouldn't I put that in Greenplum or Redshift? Probably, but you didn't. You have Hive. That's okay. Pick the tools that matter. Worse is better, right? But if you need a maintainable application, rely on some conceptual integrity. I will say, though, after all that, we will be announcing and releasing, hopefully in about a week, a thing called a Hive flow. Shove a Hive statement in it, and boom, just like Lingual, you have Hive. It will do what it can to make it conceptually consistent as a single, but you can have Lingual, Hive, Cascading, Hive, Lingual, single application, and it'll run. Sometimes you want to load stuff into Hive as a byproduct of a data flow, and sometimes you want to do some downstream stuff from the data that's in Hive. That makes sense because we have complex architectures. And so that'll be available, and actually we'll work with all the partitioning, and you actually create partition Hive tables directly from Cascading when we're done. And so it'll actually be very compelling. So you can do that. Again, if you need a JVC driver, you need ANSI compliance, you have legacy systems. So Etsy's story I told you, if they use Lingual and dropped it into a little magic tool that talks to Teradata or Teradata cluster and gives reports every morning, the exact same tool can be used against 100% of their data on a Hadoop cluster. The same, no one's been retrained to think, oh, am I writing Hive right now or am I writing SQL? No, I'm writing SQL and I'm writing SQL, right? So the intent is it's all these weird edge cases. Sometimes we have the opportunity of greenfield. We can start from fresh, and we all use cool new technologies. Most of us don't have that. I came out of Thomson, right, which is now Reuters, thanks to his people. And so we had everything. It was organic. It was awfully gross. I did a consulting gig at Tel Atlas. They bought their geospatial data over time. They had 3 different formats. It was very, very complex. That's the real world. So try to find simplicity where you can. Does that help? Okay. Sorry. Thanks, everyone.